Assalamualaikum warahmatullahi wabarakatuh. Today, we will discuss about online gaming, real-world application in distributed system. For introduction, distributed system involve the interaction between disparate independent entities, bounded common language and protocol, working toward a common goal. The three fundamental components of distributed system are processes, communication, and naming. Processes refer to independent computation tasks that operate across nodes in the system. These tasks must coordinate to achieve a shared goal while handling challenges like synchronization and fault tolerance. A compelling and ill-defined problem in the context of distributed system is like an synchronization issue in large-scale multiplayer online games (MMO). MMO relies on distributed system to host thousands or even millions of people or players simultaneously across the globe. Maintaining a consistent game state for all players while ensuring low latency and seamless gameplay is an ongoing challenge. The problem is highly relevant because poor synchronization and lag can decrease user experience, leading to frustration, discretion engagement, and financial losses for developers.
Okay, next for the challenges that we found in online game. First, the processes, which is the resource contention. It's happened when multiple processes or thread compete for the shared resources like CPU, memory, or input-output bandwidth. The result is degraded performance, increased latency, and efficient resource use. For example, in online game, with the high density of player, with the high number of player, contention happen for server bandwidth, processing power, and memory as each player compete for it, which lead to drop frame, lag, and unresponsive gameplay. For the communication, it is message ordering. Message ordering is delay or out of order message which can lead to unfair gameplay. For instance, if two players perform actions simultaneously, but one action is processed earlier due to network delays, it can create an unfair advantage for the one player. Lastly, for the naming, it is player identification. Player identification is the unique IDs or username which are essential for personalized experience, maintaining fairness, and ensuring system integrity. However, it is hard to manage in the global system as the number of players is big. Yeah. For example, two players want to use the same username, but since username are a core part of player identity, allowing duplication can lead to confusion in leaderboard, chat system, and in-game transaction as it lacks scalability and also uniqueness.
Next, we are looking at the theoretical framework. The core components of the system consist of several key elements. First, the effective computing tool, which use facial and vocal analysis to detect and classify emotion. It then encodes this emotion to personalize the training experience. Second, the rule engine, which include game rules to ensure subtle and dynamic. Pedagogy rules to align with learning objective, and training contents that adapt based on emotional feedback. Next, the device server as the interface of interaction and feedback. While the learner engage with the system to develop their skill, the process flow begins with learner's interaction through a game-based system, where emotions are identified via facial and vocal analysis. The training content is then personalized using the rule engine and through like feedback enhance learning outcome. The ultimate goal of the system is to provide additive, engage and personalized training to improve communication skill.
For each of the challenges, we have list down two of the solution. For the processes, the first one is load balancing, which is to distribute incoming requests across multiple servers to prevent any single server from being overwhelmed. It routes players' requests to the least busy servers, reducing latency and ensuring smooth gameplay. It also automatically add extra servers during high traffic, like during a game event or to maintain a performance. The second one is dynamic resource allocation, which is to adjust resource usage such as CPU, memory, in a real-time based demand. For the communication, the first one is logical clock. What it does is ensure actions are processed in a consistent order across servers. It assigns timestamp to action such as in online game like attack or move to process them in the correct sequence. It also prevents inconsistencies in gameplay and synchronize player action to fairly regardless of network delays. The second one is locking and conflict resolution. It is managed interaction with share in-game object to prevent conflicts. And lastly, for naming, the first one is Global Naming System (GNS). It assigns unique ID to player and resources. How it works is use unique identifier like UUIDs or namespace like, for example, John at NA or John at EU to ensure no duplication. Some of the benefits are scalable and collision resistant. Easy resource discovery with structured directories. And the second one is distributed resource discovery protocol. What it does is efficiently find and retrieve game assets such as map or skin in a distributed environment.
Okay, next I will discuss about the evaluation, which is I will twin the process, communication, and naming. And also I will discuss about the case study of a real-world distributed system. Okay, next I will discuss about the load balancing, strength, and the weakness, which is strength, it resolve allocation. It is because the proper solution leverage load balancer to detect server issue and redirect client traffic automatically to functional server. So it ensures the high availability and uninterrupted gameplay even during server failures or maintenance period. And the weakness, which is it is complex algorithm management. This is because load balancing algorithms are optimized for localized environments and may not account for the vast distance or varying network condition between player and game server. So it is can lead to significant latency issue where player in remote location experience lower response time and delay gameplay. Okay, next, communication is logical clock. It is because it ensures that events such as player action or in-game object interaction and it occur in the correct order and preventing conflict. Next, weakness, it is potential for delay because it ensures causal consistency across a distributed system and it will slight delays in event processing, especially when dealing with high frequency game events or large number. Okay, next, naming, which is about GNS. The strength of GNS is resource identification, which is it ensures that every player and in-game resources is given a unique identifier that is consistent across all distributed servers. But also it guarantees that each player's identifier is distinct and resources like items, assets, or in-game objects are properly identified. Second is weakness. It is centralization risk, which is it introduces risk associated with centralization. For example, if the naming system is controlled by a single centralized entity or server, it can become a single point of failure, and any issue with the central system, such as server crash or security breach, could result in widespread disruption across all the servers. Okay, next we move to a brief case study of a real-world distributed system. I choose the Amazon Web Service (AWS), which is one of the major challenges faced by AWS has been related to resource contention, which is including multiple tenants, referring to user or application. Okay, the challenge is noisy neighbor problem, which is a few tenants consume a lot of CPU memory or input or output bandwidth, reducing the performance of other tenants on the same infrastructure. Second is load balancing issue, which is a poor distribution of workloads across servers, sometimes called hotspots, where a subset of server was overloaded. Okay, next we move to approach by AWS, which is first is virtualization and isolation. It is dependent on a hypervisor-based virtualization that help in workload isolation of the different tenants. Thus, AWS reduce the noisy neighbor effect. Second is elastic load balancing, which is ELB. AWS deploy intelligent load balancing algorithm that perform runtime distribution of workloads across server and availability zones. That's all. In conclusion, online game must solve resource contention, consistent communication, and naming complexity of the underlying distributed system. Solutions such as dynamic load balancing, local clock, robust naming system, and optimized resource discovery protocol will greatly improve scalability, performance, and fairness, thus enhance player experience.